And good morning. Good morning. All right. Happy Friday, everyone. Let's get the chat on the screen. I am running really slow today. Very behind schedule. Let's back up there to where I can see it. There we go. And I didn't do little Mastodon updates. Sorry, my head is all over the place this morning. We're just getting very slowly brought up to speed here. Let's see. Let's do a little Mastodon thing. What are we doing today? Oh, yes, we are. Friday. Today's Monday. Happy Monday, everyone. Happy Monday. Oh, it is Friday. Last I checked, it's Friday. I can check again. Is the coffee flowing? No, it is not. I just have some hot water. Continuing the Lore Bastion. Set that up. Good. Boom. Done. Oh, me is on Monday. Absolutely. Absolutely. Okay, so we did that. Now we need Discord. So we toss that in this channel here. And then we also announce on our own. Boom, boom. This one gets in everyone. All right. Announcing is done. Okay. We've got the stream status stuff up over there. Oh. Oh. You are... Oh, yes. Absolutely. Today, let's update that text. Properties. What are we doing today? Same thing we do every Monday. Oh yes. Okay. Wiring together Bastion and Axum. Or the mud. Something like that. Okay. Discord link. It's... Yes, I have that. So the Discord link happens to be on the channel. It's right here. Copy link. Paste. Okay, so we're gonna pop over into the web crate. Okay, I'm gonna check the font size first. I think we need to bump that up a little. Okay, there we go. That, and now I want this window correctly sized. Perfect. Maybe a little bigger. Pink Floyd, how you doing? Oops, nope, wrong way. Oh, control minus on that. Let's try again. 37, we get about 39 pieces here, okay. What terminal emulator do I use? This is Wezterm. W-E-Z-T-E-R-M. I had previously been using Kitty. I like Kitty a lot. Just testing out Wezterm. Xenocron, how you doing? I've been using Alacrity, testing out Kitty. I think I kind of like Kitty more. Alacrity doesn't have these things. The thing I talk about occasionally but can never remember. The glyphs. So those, you know, you get the double and triple equal and the fun little pieces here. Ligatures. Thank you, Xenocron. You probably say that every time I bring that up. But yeah, Alacrity does not have ligatures. Kitty does, and Wezterm also has ligatures. Thank you, Pink Floyd. Yes. Okay. So, I have to admit, last night I was sitting in my car for an hour and a half and worked on this a little. So I'm going to bring everybody up to speed from where we left off yesterday. So this code right here, this is the web code. Okay. If we look at our little blackboard, right? We have the main piece, or our entry point. It's going to be starting at Bastion. Bastion will then have the world in it, which will be an ECS or a series of ECSs. And then we'll also have Bastion over here in with the supervisor in the web world, a number of supervisors. So these are our users over here. Like, they're like really happy. Like, yay! And they connect to some sockets on a web port, right? Doing HTTP stuff. So inside of our web crate, we need to accept connections, and I filled that in last night. So here, I think yesterday we left off just listening to a socket. Bruno, how you doing? So we listen to the socket, or we bind to the socket, then we start to accept connections on the socket. Once we accept a connection on the socket, we tell this other group, this other set of children or supervisor tree, that we received the socket and it needs to be tended to. Okay, so then if we scroll down, we have that receiver here. So the distributor, any of these children here are part of that distributor, and so they would have received this message here. All right, so we receive a new connection. We should really wrap this in its own type, like a new type, and say like, hey, new connection, or something more descriptive, because this is horribly nondescript. So we'll do that. And then here is where I left off. I would like to append a new child to a different supervision tree, but I don't know how to do that. So we're going to try to figure that out, or just attach it to this supervision tree, because it looks like we can, using the context of this client here, excuse me, of this child. So inside this child, we can get the context, we can get its supervisor, and then we can add a new child to that supervisor, which doesn't feel right. I think it is a different kind of child, and we probably need to set it up with its own distributor, and that would likely solve my concerns, but it still feels a little messy. So let's have a different message type, and let's create a new file, edit. Oh, how do we do that in Helix? I'm also learning Helix. Okay, we don't want to do the LSP restart buffer. We could create a new buffer. Create a scratch buffer. Okay. We will write that to web source. And we're inside of here. Let's just say message.rs, and we'll just toss our messages in here. Okay. Hub, create, struct, and what shall we call this? New web client, new web connection, new. And this will just contain the socket, which would be a Tokyo net TCP stream. Boom, done. Okay. Let's go back over to web lib. Let's wrap up the socket. Oh, we could also add the sock adder. Not sure what we would do with that though. New web connection? New web client? This has a little Christmassy feel to it. What is this? Farm life in autumn. Oh, it's so close to that other song. Okay. So in this case, we will tell it that we need this new web connection, which I probably got wrong. Nope, new web connection. It's just here. Mod message. So that should work, yes? Whoa, whoa, whoa. New web connection doesn't implement. Oh, debug. Okay. Sure, let's do that. Let's. Perfect. Now, for the receiving side, we receive a new connection. receive a new web connection. Then we have message. Where's message being used? Here. I see serve connection message dot 0. Okay. Just to get that set up. My browser just moved a little. Anyhow, so let's see, where are we here? So we have this with exec piece. Okay. How about we move these to their own functions? This is getting a little too busy. So when we receive one of these, with exec wants what, a future? Right, where the output is just that, okay. So it receives a Bastion context and returns a future. Got it. Drop that down there for a moment. With exec, handle new connection. No, I grabbed way too much stuff here. Okay. Function. Now this needs to take a context and return a future. Context, Bastion context, yes, thank you. And this will return an impl future with standard future. One more. Okay, there we go. So async move will be what we are trying to return. Need to get the brackets correct, and it should auto format. There we go. Okay, so we're returning this async block, and all that this does is loop. Great. Receives messages. Handle new connection. I don't know. It's. I don't like the word handle. We could describe this as new connection child. How do we rename things? Rename symbols. Okay, so space R. Ooh, look at that. New connection. New connection child. Okay. Now we have our Bastion context. That should be fine. Okay. We see this little tracing. I received a socket. Now at this point, I didn't get very far. Import or qualify. Let's qualify for now. It might move. Then we have HTTP server. Oh, that I started here. Oops. Come on, just go down. That will live outside of the loop. Okay. What's going on here? Expected result, found connection. Okay. But this is a child, right? That needs to be here. Semicolon there. Did I get this wrong? Oh yes, we don't want that semicolon. We do want this one. Captured variable. Can it move into there? No, because basically we need a clone of that, of this HTTP server for every loop, right? For each one of these children. It's clonable. Captured outer variable. It's interesting how it points this Helix client. Not move out of HTTP server, a captured variable, and an FN closure. Move out of HTTP server occurs. Cannot move out of message.0. Interesting. So message is here. I want to see the bigger cargo shack-p web. And what do we have? Context, captured outer variable. Oh. Did I put the copy at the wrong place? Is this also going to be open source? I don't see why not. Let's say the game engine, yes. The content, no. That's currently where my head is. How many times do we have to clone this? All right, once for the supervisor children. And then once again for the child exec. Because this could happen more than once? No, it shouldn't. That should just be moved into there. But then in here, does it happen more than once? Or could it? I don't think so. My kids have recently gotten phones. Oh. I'm gonna ask her if she has any more puns for the stream. Wrap the move in another block. Oh, this one here. Could do with exec move, context, async move to see what it's pointing at. Make a move the HTTP client to. Oh, this one. Yes. Getting Starlinked. Uh-oh. Okay. Let's see. Line 85, that's being captured. Captured by this function. Did I not add a move? No, I don't need one there. Okay, so it's saying that it's getting moved here. That just takes a reference to self. So this closure, clonable for the future, right? Here, before this future. So we have it cloned in every place so far. Wait, which future? We've got 1, 2, 3 futures? Got one. Oops. Sorry. The async block. Oh, Museum. Which... This one. I presume you're talking about this one. And not the line 74 one, but you're talking about line 86. Okay. Am I thinking about the wrong variable? Because we are... Right, that one's captured. Let server equals server.clone, async move. Here's the context. Oh, here. It's a loop and probably whatever that macro does. I see. Add all the clones, right? Okay, We could. So in terms of the server, I'm not certain. Well, it just started there and it just kept going deeper in. And yes, it could absolutely be made right next to this, right? Absolutely. However, I would like to take this learning opportunity to figure out WTF is happening. Right, because of this, captured by here, moved due to use in this generator. Wow. The future takes ownership of it. Yes. Which should be okay, right? So line 87, it gets that. That seems just fine. It doesn't take an FM1s, which means, yeah, oh, it could run it multiple times. Oh. It takes an FN, I see. Okay. So if this gets called multiple times, well, shouldn't this clone have... Hey, Groovy Man, thank you for that raid. Thank you. How you doing? How was your stream? Happy Friday. And welcome. We are currently looking at some lifetime issues. Well, not lifetimes, it just captured. Because it's already captured in the closure. Right, so HTTP server is captured in the closure. Am I now doing game development? I do different things. My passion is game stuff. But I don't usually work in game stuff. I just like games. I like the technology. All right, let's move that up. Okay. I'll move out of message.0. Oh. Oh, that is disappointing. Oh, my daughter did have some. All right, here's a good one. If a pig loses its voice, does it become disgruntled? But-unch. Well, thank you. And hello, happy Friday. I see, because this here could be called more than once. This message could then be used by multiples. So this serve connection, which likely takes ownership of it and not a reference. Okay, so how do we create a child that does not have this, like... If this child dies, there's no chance of getting it recreated. You just don't, right? Because the socket's gone. Or is it? If the child dies, the socket might not be gone. Ooh, that's weird. Oh, that's interesting. Okay, so we get this new connection. We're trying to start a child. The problem is that we might need the child to be copyable. In case this dies, it needs to start it up again. Oh, creepy. Okay. Now, would I want that or would I want this just to go away? It would be nice if it could just pick up from where it left off. We might be able to do that. So we have the socket and this new web connection. Then we move the socket inside these two blocks. We have a supervisor, then we have a child inside of the supervisor. Interesting. Now this serve connection, what is this looking for? For IO, it wants something that's async read, async write, and unpin. Okay, can we give it that? Using the Tokyo stream, can we clone that Tokyo stream? Oh, you know what? Let's use local docs. Oh, but it's broken. Go. Docs, open all. A doc, singular, sure. Okay. If you split it, you'd have a cheap block, a bylock, but only 2 owners. I see. Otherwise, we need a mutex. Oh, you'd have problems if it clones. Ew. All right. There we go. Copy link. What are we doing here? Moscow Bish? Drop thing. Okay, so we have test here. Cannot move out of thing. Captured variable in a function closure. Okay. Has a macro for it. I think they came up with a very clever trait. Interesting. Rust capture semantics are rather basic. You can see the fix on the bottom. Okay. Oh, the second version of the code is the fix. On the bottom of the code. This here. Gotcha. Gotcha. Okay. Oh, yes. I don't know why I'm just uncomfortable with that. You're right. Okay. I wonder if that would work. The actual problem here is the async blocks capture semantics for the generator. Not a clone. Oh, not the closure. Oh. Oh, but what would we do with message? In this case, message, we would have to clone it or whatever, right? Get that mutex. Disjoint borrows for closures which fix most of the ergonomics, but disjoint borrows and generators are a hard problem. Disjoint borrows. The problem here is that is the message now, right? I'm just making the code compile. So, okay, yep. It'd probably not be enabled for async closures. Interesting. Disjoint borrows are basically a closure can be thought of as a struct that borrows what it closes over, right? Oh, let's pick different lifetimes per borrow. Got you. You know, I was going over my Today I Learned emails from forever ago and came across some notes on Musi and you explaining how closures are implemented. And so that absolutely makes sense. That the lifetimes here are the problem. Now it can have each borrow be disjointed and have different lifetimes. Oh, wow. Huh, that's cool. I want to look at the API. Yeah. TCP stream. But having a lifetime change between awaits is the hard problem. Ooh. Okay, so if we did the into split, we get into the split owned. Oh. Then later, could we reunite these? Okay. Such as enum future. Oh no, it generates the B, but then it needs to change the data borrow normally to extend it. I read the same one, Moscow Bish. Async move. And move. Force it to not borrow anything. I see. Wow. Okay. I was going to tell a joke about mud, but it was too dirty for this family-friendly stream. Okay. So let's say we have... What's the order here? Is it... if we want to do a split... Read half and write half, okay. Oh, but that's an owned read and write half. Ooh, no, we can't do that more than once. Okay. Oh, interesting. You're going to bring Polonius into concepts, into current Rust C. Well, that's cool. So, oh, we could just do split, which gives us a read and a write half. I was looking at the wrong thing. Okay. Then how do we get a read-write stream out of that? The halves cannot be moved into independently spawned task. Alright. Okay, so I thought there might be like a join Tokyo. Here they have pair. So we have unsplit on half, read half. But that's not the same as Tokyo net read half, or Tokyo. We have TCP stream. TCP stream takes us into split. Split gives us a read and a write half. The read half So Tokyo net TCP read half. Now which impulse async read. What am I trying to do? Unsplit, yes. Unsplit because the API here, serve connections, requires I to be async read and write. So writer reunite, I think that only exists if you do into split. So if we take the write half, they don't have a reunite here. Try right, try. It's also reader, but that's for into split, right? And if we do into split, we have the same problem because that consumes self, whereas split doesn't. I dropped the read and the write, you still have the TCP stream. For both splits, you can just drop them. Yes. Okay. So the difference here, though, right? If we use into split, which is where these reunite pieces live, so it reunites here on the owned read halves, but not on owned read half. Owned write half has the same thing, but it's not on the read and write half on these two. So these two, which we would need, you don't need to join the borrowed ones. Really? Because you'll still have the TCP stream around. Am I thinking about this upside down? What's... But I have to feed something into this function, right? Into the serve connections, and it takes something that is async read and async write. So don't I have to like put them back together to fit them through this hole? Okay, so let me just write down what's in my head. Read half, right? Write half. Then we have message dot split. TCP stream. Just keep using your TCP stream. I'm lost. I gotta admit. It's like dropping the stir and then okay. Because okay, so we have to pass something in here. What do we pass into this? Maybe let's work backwards. What do we pass into serve connection? Because to me that's some sort of, you know, TCP stream, right? Oops, what did I do? We have a TCP stream. Or a async read write thing, but where do we get that? Right? If we message, let's see, .0 split has to come from somewhere. So we have our TCP stream, which lives inside of this message piece, but we can't pass that in here. Okay. All right. So are you saying that I comment this line out here, line 84, and that we pass in the TCP stream, which is message.0? Because that doesn't work. Right? I thought that's what you guys were saying, or y'all were saying, oh, I needed to be explicit about the capture here, right? And in order to copy the socket or make the socket available internally I would need to split it and then make something together that I could pass into the serve connection. I feel like I'm being really dense today. Either that or y'all are trolling me. And so, oh. Yeah. My child needs to restart, which means that we have the split, right? And we could do something with this. We could make something that's async read and write. Maybe we could give something two halves that looks like that. What you could do to handle shared connections is use an MPSC channel and a spawn task. Learning lots, watching. Huh? Well, welcome. I'm glad. I'm also learning quite a bit here. Like this pattern here. See, I'm actually gonna. That should have sunk in a long time ago. I'm gonna grab that. Where was that? Copy that. That's going in my Today I Learned bucket. This is 2/3/2023. Oh goodness, that's horrible. Paste to match style, much better. All right. All right. Wait, I don't get this either. Why is moving the message not possible? Because this child might die and get restarted. That's not an FN1, so it's a FN. So this child in Bastion, let's say there's some other error, right? Let's say, you know, I do something stupid, right? Leaving an unwrap, whatever, it makes it to production. And this child inside of Bastion dies, right? Then using the strategy, supervision strategy 1-for-1, Bastion restarts it, right? And this should be mostly stateless over here. So we should be able to reset up our little pieces here, but that might not be the case. Catch on what? Okay. I have an idea. But it basically means that we would never be able to restart this. And I wonder if Bastion has support for that, like supervision strategy, let it die? Like what? For one for all, 2 owned. Don't raise the dead. Okay, we can work with that though. Basically, there's this little trick that somebody in the channel taught me a long time ago that we could basically toss something into... Oh, can we do that? We could basically just put this inside of something, right? And then take it out. That something still exists outside, but it's empty. So the second time we try to start this up, it fails. Right? That would kind of suck. So maybe I'm using the wrong mechanism inside of Bastion. Bastion. Let's bump the font up. I should just use the web ones. They keep my font size correct. Docs, Bastion. issues, the crappy Starlink internet. You know, I'm wondering about that. You know, it's better than it was before. Is it though? I don't know. I say that, but now that I think about it, it caused more, well, different kinds of hassles in my life. And you are correct. Yep, there's stream. There's little shenanigans going on. So in this case, we got a little graph here. And yeah, there's some little networking shenanigans going on. Okay. So we come back here. I don't think that this is the right pattern here, but we could use it and work around it. Basically, we stuff this socket into something that exists outside. Inside, we, like, let's say it's an option. Let's pretend it's an option. First time we run through, we take it out of the option. Option still exists outside. Fine. Second time, let's say it crashes. Second time we start this up, say, hey, there's no socket in this option. I retire gracefully. Right? That's possible. Oh, just wait until I hit my 1 gigabyte cap, or 1 terabyte cap. Terabyte. Okay, so we have a supervisor, right? Context dispatcher distributor. Okay, no. Envelope, no. Supervisor. I see. So we can do that. We have, what is supervisor with callbacks? Oh, interesting. Okay, with restart strategy. What about children? I'm gonna change the song. It's got a little something in it that doesn't quite agree. Oh, what happens when words break the law? Another gift for my child. They get sentenced. I can't. Moscow Bish, we are using Bastion to learn Bastion. That, and because there's a certain, you know, I'm attracted to certain things, right? Like my taste in women. Right? I have a certain taste. It's just there, right? I can't help it. I also have like a certain fondness for supervision trees. It's just there. I don't know if I can really help it. It's there. I found that when I was flirting with Erlang. Erlang's like, hey, I've got these supervision trees. And I was just taken. I was smitten. But I found it wasn't really Erlang that I adored, but it was the supervision trees. All right, done with that. With exec, what is it? Okay, this is what we're doing. Callbacks. Oh, that's so we know before and after. Fine. Buff writer is also neat, is neat because it also implements async read, spawning a task for the connection. Oh, let's go look at that. GitHub. Where's Bastion? Source. Great idea. Spawning a task for the connection. Why don't I do that if I don't care about restarts? Yeah. Well, it would be nice if we could do restarts. It really would. Message passing to the task that does the actual read writes. Yes, we could. Okay, so Tokyo Axum calling out to Bastion. The task itself cannot read or cannot write. Okay. The other thing that I wanted to eventually connect this was the ability to use the Bastion message sending to the live views. Right? That would be really neat. It doesn't have to be Bastion. Sorry, let's come back here. Copy. TCP server. All right, so they run, they get a handle, TCP listener bind. Wait, what is this handle piece? That in Bastion Prelude? Oh. Handle wraps, it's wraps IO element, it's completion channels. Bastion's IO driver nuclei. Interesting. Okay. So they tossed the listener into a handle. I didn't do that. Have an accept loop. Right, so then we just... Oh, this is for Windows. Wait. Oh, this is not Windows. This one is Windows? Why is there a difference between the two? Oh, this one's standard net TCP list. Oh, I see. Spawn. Where's spawn? So we call spawn. That's in Prelude? Yes, so that's... Which one is it? Is it in the Prelude? It must be in the Prelude. Okay, Prelude spawn. Oh, Windows TCP uses IOCP. It can handle async better than just using epoll. Oh, I see. Okay. So that just spawns a task. Got it. Let's echo and stream IO copy. It's going from one place to the other. What? What is this IO copy thing? Back here, IO. Futures IO. Ew, okay. It's a feature which copies all the bytes from one object to another. Okay. Oh, they're copying it back to itself. Oh. Okay. I was wondering what is this magic? And okay, it's echoing. We're just sending the bytes right back at you. Gotcha. So far, all of this pretty much just isn't Bastion, right? They've got the handle piece here. The handle piece. The rest of it's just Tokyo and TCP. Bastionnet. Here we have children. Let's have TCP 10 TCP echo servers. Okay, so basically, sure, but it's not a great example, right? Okay, so I mean that's not super helpful here. And just some thoughts. Let's say a WebSocket is established. Okay. And so the WebSocket's established. That means it's gone through the upgrade process and something happens on the back end. All right, we lose that state and we attach HTTP to it again, right? Using that serve function, serve connection. It's brand new, right? That means that the client and the server are out of sync at this point. So ideally, it would be better to reestablish the connection. So we can go that route where we just shut the connection down if an error happens. Now, if we go back to that live view piece, here we can go back to an example. We have examples. Okay. When we mount one of these live view pieces, we need to be able to give it some sort of information, basically a way to give it information. We need some way to give it information. And I was hoping that in here, we could use the Bastion messaging system. So how do we get from where we are to getting Bastion messages over here? That's the big challenge. Okay. Where do we go? So the goal is to have this be inside of some sort of event loop. And if we try to work backwards from this, this would be a Bastion child. Each one of these views a Bastion child. Interesting. But that does mean we could spawn... Okay, different question. With Bastion, can we attach a child to some other supervisor? One that we don't know? Essentially, we need to give this handle these pieces, right? So mount, it could do whatever it wants with these, couldn't it? So mount could really just send this information to something else. Okay, and that's really what I'm looking to do. Could ask a child for a supervisor ref. Yeah. Okay. And just for completeness, let's see. What other examples do they have? Cluster, let's see, Fibonacci, getting started, hello. Parallel computations, prime numbers, okay. Scaling groups? Descriptions would be cool. No readme in this folder. Not what I'm looking for. Or no. Let's look at parallel. Little map reduce. The shadowed shareable reference of workers. Okay. But workers. Oh, interesting. And what do we do with workers then? Oh, look at that. Our little friend, our pattern from today. Controlling the context that's being captured. A mapper that generates the work. Okay. And where's workers in here? Workers clone. Distribute your workload to workers. Okay. Someone from the Bastion team wrote a blog post about integrating Tide with Bastion. They basically used an approach I outlined before. The server is just running on Tokyo itself, but the dangerous handler logic is running on Bastion. That makes sense. Okay. So let's basically back out and do that. Right? Okay. Ooh. And I need to check my calendar real quick. I got a couple minutes. scanning through it. Prime number children, okay. Man. Fascinating. Okay, so back to the code. So let's plan out tomorrow. You can use the distributor API, which we haven't looked at. That would be interesting to see. API is newer than the blog post. Oh, let's look. Let's look. Okay. We are using this for sending the new connections. Gotcha. It's kind of like a little pub sub thing. Okay. On question. Oh, I see. It implements message handler. Or it's a, okay. Doesn't impl. Message handler isn't a trait, it's a struct. Okay. Yeah, these are very kind of Erlang-esque. Well, I need to run. So our plan for next time is to move. Where are we? Go back to where we're talking about. What we're talking about. We will move these pieces out. The listening to the sockets, we'll just use straight up Actix with that. We might toss it into a child or something, who knows? So we can control it with Bastion. But other than that, I think we'll just use it for its default stuff. And then once we get to the point where we are looking at, where's our live view piece? The live view piece is for mounting. We'll basically toss this work into childs. So we'll move these pieces if we can. Some of this I don't think matters. We'll see. I'm curious about view handle. can we do with view handle? Clone. Okay, well it has clone. So that should be enough for us. All right. And what is self.tx? Oh, an MPSC center. Okay, perfect. Description is what I consider to be a query, a type query. Also have been going deep into salsa, so. All right, y'all. Thanks for hanging out. We had a couple of little mind-bending pieces in there. I got reintroduced to that little kind of closure, I don't know, capture pattern? What do we call that? Let's see, who's doing Rust today? Mr. Halsey's doing Rust. Reinventor of wheel. Pokemon scraper. Cool. All right, let's write reinventor of wheel. What are they doing? German. I don't understand German. I don't even know if they're actually talking in German. They might not be. All right, y'all. Well, till next time, take care.